we've got some new science this week. Yeah. So this week we have some scientists, or I think they were doctors, maybe, whatever. Scientists or doctors are scientists. Some doctors, anyway, not those pseudo-scientific doctors. Anyway, so basically they found a way to, they accidentally found a way to turn cancer cells into immune cells. So I'll do this screen share here. Let me know when you guys can see it. Cool. Scientists convert cancer cells into harmless immune cells. So basically here, from what little bit of reading I did on this, and I actually saw a news article on it earlier this week. I thought it was not a real news article because, I mean, that's kind of hard to believe that they found a way to convert cancer cells into immune cells. But basically, you can read this here, or you can just listen to me talk about it as usual. So basically, they threw everything they had at this aggressive cancer, and seemed like nothing was going to work. And then suddenly they noticed that what they were doing started to change the size and shape of the cancer cells into what resembled white blood cells. And so basically with this new science this week, we may be able to use this in the future to combat cancer. And note this area down here where it says the researchers also have reason to believe that these converted cells will not only be neutralized with regards to their former identity as a cancerous cell, but they may also help the body mount an immune response against other cancerous cells lingering in the body. This is huge to me. Like I said, I saw it earlier this week, and I thought that it was fake because, you know, you see a lot of stuff on Facebook and stuff like that about people having these cancer cures, so I didn't really believe it. But then, you know, I actually saw a paper on it. I'll put the link in the comments section, and then we've got the I Fucking Love Science link where they're talking about it. So it seems to be pretty legit. Let's talk about this. What do you guys think about this?
Well, I know Dieter in the comments here said that it's works only for a specific type of cancer. I would say that, yeah, it's really important to find that one specific type of cancer that we can do this to, because then we can see, you know, kind of why this happens. We can look, you know, as to the reasons why it happens, and then we can change it for different cancer cells, you know, different types of cancers, if that is even possible, depending on how it's actually changing the cells. So I think that it's still very important, even though it's just for one type of cancer. I think that it could potentially lead to a lot more valuable research.
Yeah, I agree. I mean, this is obviously very exciting. And like you said, this seems like science fiction. Doesn't seem like something that could actually happen. So yeah, I mean, at least for this type of cancer, that's pretty amazing that they were able to do this. You know, and hopefully whatever, you know, pathway or mechanism that they determined that they could you know, use this for this type of cancer, maybe that will be possible with some other types of cancer as well. You know, obviously there's so many different types of cancer, and we all just kind of put it under this big umbrella as like one single disease, but obviously they affect different types of cells and tissues and organs, and they don't all work the same way. You're dealing with different genes and all this and that and the other, but you know, maybe there is some kind of pathway or mechanism here that might be analogous in other situations. But it's just, you know, it's good to see regardless, even if it only is good for this one cancer, it's good to see that, you know, there is progress being made, and that our, you know, our research and our funding is paying off. And so, you know, this will be very important for anybody who has this type of cancer in the future. That'll make it, you know, readily treatable. So very exciting stuff.
Yeah, I think this is a great thing, and I mean, obviously it's a great thing, right? But I think we could make a broader point about just sort of an attitude of discovery and scientific experimentation in general. The idea that scientists have to work as if they're atheists, right? Meaning specifically that if you want to attribute everything to a supernatural cause, you're not going to investigate it further, and it's very important in a progressive society, in a technologically advanced society, that we don't operate that way, whether we believe that or not, right? it also brings to mind the idea of playing God. I think there are probably a lot of people who would have been scared off by this type of research in the first place, had they been made aware of it. And that's a phrase that's thrown around all the time, is that scientists are playing God, and that's what we talk about with cloning and all sorts of stuff like that. But I think it's important to remember that that phrase doesn't really mean anything. It just means that we're experimenting with stuff that we don't understand, which, of course, is a huge foundational principle in science, right? And that's what leads to discoveries like this. So it's important for all of us to remember, regardless of our religious orientation or anything like that, that there are times, at least, and I think all of us on the panel here would argue that those times are always, but at least there are some times when it's more appropriate to live as if there's not a supernatural explanation for everything.
Well, it's actually that actually worked. Okay. So I was reading more about this because I saw the link on Facebook or something, but I was like, oh, neat, science is magic. Moving on to other things. But now I'm actually reading about it, and it seemed like this is like the most serendipitous sort of deal ever. In very layman's terms, so that I can understand it, the way that this actually happened was they bathed the particular type of cancer cells in like a stew of various growth factors, transcription factors, and various nutrients, and some of them just spontaneously morphed into white blood cells, and they're just like, oh, that's kind of neat, and like, wait a minute, let's see if we can go a different way with this instead of just ignoring it. And they remembered in some other experiment that if you give a certain kind of transcription factor to progenitor cells in mice, then it can have a very similar effect. So they're like, okay, let's just keep doing that. And it turned out that this worked, and they're able to make effectively a lot more white blood cells out of cancer that can go after the cancer. So you force cancer cells to become cannibals, which works for me. And it's definitely cool, and it definitely works in this very specific context. But the one reason I wanted to bring this up was this is one of those kind of deals that I absolutely love science, because they weren't trying to do this. They just were like, hey, this is a thing that's happening when we're literally throwing chemicals at cancer and seeing what happens. Because we're scientists and know what we're doing. And then it just kind of went in that something worked. They started investigating further, and now it works even better. Science is just fun sometimes.
If I can make an analogy to this situation that might really get some more layman people, I guess, to understand. Think of this as The Walking Dead. Okay, you've got this mysterious chemical that comes in and infects these certain cells, and then these cells turn on the other cells and eat those cells, and it's just like zombies. I mean, you got this hidden agent on The Walking Dead that comes in, turns people into zombies. Doesn't matter, if you get bit or not, because everybody's infected already, right? And so you've got the white blood cells that come in, and then they eat everybody else, and so it's just kind of like, that might not be a very good analogy, but it's what it got me thinking about it.
I thought that I did the layman's terms very well. Dieter attempted it, but it was still pretty bad because I'm sure most of our viewers have no idea what transcription codes are. I don't even know
who doesn't know what progenitor cells and transcription factors are? I mean, let's be real.
Okay, but on the serious note here, we mentioned in the chat that this is for specifically leukemia. I just wanted to note, especially to Dieter, that a lot of things that we figure out and discover in science do happen to be accidents. That doesn't take away from the title of being a scientist. It just means that we're people out here that are trying to fix things, change the world, discover things, and sometimes what we do is an accident, but if you didn't take that initial step towards it, you wouldn't probably get there. It's also important to note that this discovery is really important because, as far as I know, it's still 20,000 people that die every day of cancer, and I think that it's once every 10 minutes someone dies of a blood cancer. So the leukemia type cancers, I know it can deal with bone marrow and other things like that. It's not always a blood cancer, but if you save one life, is that enough? Yes, it is.